Hey everyone, how are we doing? Just making sure we don't have an echo to start. But if you're here to watch the chapter 16, we're going to get started here in just a second. Feel free to say hey if you're in the chat. I don't know if we have anyone watching. Maybe we do, maybe we don't. We'll find out here in a moment. But with this said, I'm going to put a disclaimer. Disclaimer. Let's put a timestamp. Disclaimer. The biggest thing I can give you, and advice for the test I can give you, is stop every question before I complete it. And also, I'm going to give you kind of tools for solving these questions, how I solve them, how I know the answers. So my biggest disclaimer is don't just try to look at the answers. That's, I mean, I probably would too. I'd be like, oh, what's the answer to this one? But try to like pause each question and think about, well, how would we know the answer? What in this question indicates the answer? And then the more you can get, like without me showing how to do it, the better you're doing. So the goal is of this video and why I'm doing this is that you have more walkthroughs, you have more communication of these ideas. And when you get to task questions that you have to be like, okay, what's the null and alternative? How do I solve this? Well, then you've got the tools to solve it. You'll know like, okay, I know how to write the null for this. I know which one the null is. So without further ado, let's get started on here on chapter 16, homework 1, question 1. Okay, let's do it. Here we go. Okay, so take a pause and see if you can solve this. This doesn't show the whole question here to start. But remember, always start out each question with seeing if you can solve it. Now, the number one thing, and they've already given it to us, is they've given us the equal sign right here. The null always has the equal sign. So we are going to choose something right here. We've got the equal sign right here. So we're going to say the null states. If you watch any sort of videos where I write out the null hypothesis, you'll see anytime I write out the null in statistical notation, looking for one of my notes with it, you'll see me writing an equal sign. So the null has the equal sign. So we've automatically got that. Boom, equal sign. The null states something is equal 0.07. Well, the something right here is the parameter we're measuring. So whatever we put right here is what we're measuring, and then this is the hypothesized value. So what are we measuring? And that's what it's talking about up here. We are going to measure, a casino wants to know if a slot machine really delivers the 7 in 100 win rates it claims. So would that be the mean win rate or the proportion of wins? So that's where you're asking, is it categorical or quantitative? If it's categorical, we could say the proportion of wins is 7%. If it's mean, we would say the mean win is 7%. But like mean win would be the amount you win. Like someone wins on average $5. But this is the proportion of time people win. Like, did you win, yes or no? 7 out of 100 people, the casino claims, will say, yes, I won. So this is going to be proportion. Now, since we put proportion, that means we're talking about P, which is the true proportion. So let P equal the true proportion. And so we'd say the true proportion of people who win at the casino is claimed to be 7%. And that's how this statement would read right here. Now, the only things you could put are mu or P. We would not use X bar and we'd not use P hat, because whatever you put right here is the truth. So we'd have to say the true proportion, not the sample proportion. So you wouldn't put that there. P hat, it'll never be used when writing nulls and alternatives, nor would X bar. If it's quantitative, it'd be mean, and if it's proportions, categorical, it would be P. So the true proportion is equal to P, which is the proportion of people who win at the casino. They claim it's 7%, so we're going to assume that that's true. And we want to see if it really is that. Now, they don't give a sidedness to this. So since they're not directing, is it less than this? Is it greater than this? We're just seeing if it really is that. So if we're seeing if it really is this, the alternative would be that it's not really this. Watch me get the first one wrong. That'd be amazing. But we didn't. I've done these a few times. So the null is that it is 7%, and the alternative is that it's not, just saying it's not. Okay. You could actually change this question to a casino question because all it is money. So this is a quantitative value. It's the first thing I immediately see when I see this question. It's a customer spent on average. So that's a keyword right there. Average $44.65. So we're looking at how much is the average amount that people spend at this website. You could just change it to the amount that people were winning at the casino in the previous question to say, we have a claim that customers are winning $44.65 on this casino. Based on a random sample, the company wants to know if the mean this year has increased. So you could change it. The casino wants to know if people are winning more money this year. Now, I've noticed when you highlight the words, how this word doesn't highlight. That's how my Pearson is actively changing these words to see if it's like increased, decreased, or changed. This goes to the sign of the alternative right here, the claim. So we want to see if it's increased, which is going to be the greater than. And then the null has the equal sign. The null always has the equal sign. So anytime you write a null, you want to say something equals something. The claimed value always goes in the third spot. So notice how that doesn't change. It'll always be something equals something, and then something, and then we only have less than, greater than, or not equal to. You don't use the equal sign over here. And don't use greater than equal to. It's less than, greater than, not equal to. So now we just have to know the first part of it. Remember we said it's quantitative, that this is money. So since it's quantitative, that means we're going to be talking about the true mean, and that's mu for the true mean, and that's going to be here mean. So the true mean is equal to the mean of this. It's just saying that this value represents the mean of customer spending on the website. I just call it the true mean, the population mean, and we'd put that right here. So whatever you put for there would go for these other spots as it does down here. So that is the true mean right there. Oh, we got one more. A pharmaceutical company wonders if their new drug has a cure rate lower than, look at when you highlight there, it is lower than 40%. So the claim is 40%. So we're going to believe that 40% is true until we have evidence that it's lower than. That's what they're investigating, which is the alternative. They need evidence to believe this. And they're wondering if people have been cured. So it's a good point right here to see if you've been following along and you're like, okay, wait, were people cured? You have to ask, is that categorical or quantitative? So just go up to someone and be like, were you cured? And if they say 5, you're like, okay, that's quantitative. If you go up to someone and say, were you cured? They say yes. You're like, okay, that's categorical, which is the proportion of people who are cured. So I think you get, this is a categorical question. Were you cured? So when we ask, we would get the proportion of people who are cured, and that's going to be, we're analyzing the true proportion of people who are cured. We're assuming it's 40%, and then we're seeing if there's evidence that's less than 40%. So there we go. Good stuff. One more. A bank wants to know if the percent of people using their website has increased from 30%. So once again, go to the way you ask the question. You would go up to someone and say, hey, do you use the website? If they say 8, you'd say, oh, okay, quantitative. But that's not how people would respond to that question. The question, do you use the website, is a quantitative question. And this what we're doing right here to figure out quantitative or categorical is going to dictate, since it's categorical, I do use the website, it's going to dictate that we want to know the true proportion of people who use the website, not the true mean. Remember, they're responding, yes, I use the website, which is a proportion of people who use the website. And this automatically, as we've seen, identifies the first part of this, what we're analyzing. The null has the equal sign, and the bank wants to know if it's increased, which means we're asking, has the true proportion gone up from 30%? These are excellent questions for doing the null and alternative and knowing when to use categorical versus quantitative. Really good stuff. I thought we had one more. I was like, whoa. Okay, on to question 2. That was a good question right there. Chapter 16, homework. If you're in the chapter, please say hi. I got some Coca-Cola, a little bit of energy right here. So we are streaming, I think. This one says a company is being sued for job discrimination. They're being sued for job discrimination because only 13% of the newly hired candidates were minorities, when 30% of applicants were minorities. Is this strong evidence that the hiring practices are discriminatory? So in this, they want to know if it's a one-tailed or two-tailed test. The idea of one-tailed or two-tailed goes to the sign of the alternative. So if I say if something is a one-tailed test, your choices for the one-tailed test are going to be the greater than or the less than. Generally, this would be when you're more towards evidence of greater than, more towards evidence of less than. I guess technically for consistency, we should put the line in the same spot. And there's the greater than, there's the less than, and the two-tailed is when you draw on both sides of it. You do a reflection of where your results landed, and then you reflect it. That is not symmetric to the curve above, or not equal to, but you would reflect it on the other side. So one thing I like to point out about this, that top curve is the one causing the issues. A good bit of knowledge for you. Wow, I cannot draw normal curves today. I have drawn too many normal curves. Let's draw some real normal curves here. You ready? Normal curve 1, normal curve 2, normal curve 3, good to go. And we'll put our line down, and we'll make it a little further, or a smaller result, and then we'll draw the, here we go. So this is the greater than, the less than, and the not equal to. So with the greater than, you shade to the right of it. With the less than, you shade to the left of it. And with the does not equals, you shade both sides. I like to show like a arrow coming off this going both sides. So it's just a reflection. A really good small test question is ask for the p-values. If we have a p-value here of, let's say, 2% or 0.02, we'll do it as a decimal, as it usually is shown. then the p-value right here would be 0.98. These two add up to 1 because they shade 100% of the curve, as you can see by going left and right of a line. Now, the bottom one right here is double the smallest. So notice how all you're doing is just reflecting this on the other side, i.e. doubling it down here. So these p-values have a relationship where the less than and the greater than add up to 1, and the does not equals to double the smallest. Now, the question wants to know which one of these are we using? And it goes to, are we asking, is it increased, or is it greater than this? Is it less than this, or is it not equal to this? So think about the way you would do a court case. Would you be asking, did they hire too many individuals to discriminate? Did they hire too few individuals and they discriminated? Or did they hire like not the right amount? Theoretically, someone could do the last one, but most court cases, if you are on the side of I guess the prosecutors, you'd probably want to do a one-tailed test trying to show evidence that they hired too few. So one-tailed because they're not going to be like, we're just seeing, did they hire less than what we would expect? So is it less than the hypothesized amount? They're not going to be sued for hiring too many. They're going to be sued saying you hired too few. This is really good type 1, type 2 error stuff, and it goes back to our courtroom trials. So when you think about the courtroom scenario, we've actually got a little bit of stuff set up, right? Oh, we can just do a blank page. When you think about the courtroom scenario, we start off in a courtroom believing that someone is innocent. And the alternative, which we need evidence for, is guilty. So, or not innocent. Sure, why not? Let's go guilty today. So the null hypothesis is that somebody is innocent until we have good reason to believe evidence of their guilt. And with this, we have to know what a type 1, type 2 error is to answer this problem. In a type 1 error, there's a 1. The null is true. So I want you to look at this, and this is the best way. Just slow down. You look at this right here, and you say the null is true. That is a true statement. Like, just stop. That's true. But think about errors. If that is true, they're going to make an error, and they're going to reject it. And this means that they are found guilty when they're in fact innocent, so they did not discriminate. So remember, in a type 1, null is true. That's just a true statement, just fact of the matter. So in this, what is a type 1 error? A type 1 error would be deciding the company is discriminating when it's actually not. So that is a type 1 error because the company is innocent, but we reject the null and we say we have evidence of their guilt. Type 1 error. Null is true, but we accidentally reject it. In a type 2 error, it's going to be just the reverse of this. So in a type 2 error, and repeat after me, in a type 2 error, the null is false, and we fail to reject it. So that's how you do it. Type 2 error. The null is false, and we fail to reject it. There's 2 F's in the type 2. Great way to remember it. Once again, repetition, repetition, repetition. Type 2 error. The null is false. That's an F. And we fail to reject it. So this is a false statement. And we're not going to reject it, which means we're going to stay with it, which means this was true. But we are not rejecting the null. So it's true the company is guilty. The null is false. That means this is true. The company is guilty. But we did not reject the null. We stayed with it. We failed to reject it. Failed to reject the null. It's the second F of the type 2. We failed to reject the null. That's a huge pen. So with this right here, the null was false and we failed to reject it. So the company was guilty, but was not found guilty. So in a type 2 error, it is deciding the company is not discriminating when it is. So the company was guilty, but we didn't find out about it. In context, what is the power of a test? Now, the power of the test is the ability to correctly reject the false null. And we have a bunch of stuff right here. So we'll go to the teaching screen for a second. I've got the keywords underlined that you need to know about power. Power is the probability or ability of a test to correctly reject the false null. It is a probability, so we can do a power calculation to figure out what is the probability we correctly reject the false null, given a certain effect size, alpha, and sample size. Those are the 3 things right there that control power. I put those on note cards. Effect size, sample size, and alpha. Now, each of those is positively related to power, as in larger effect size, sample size, or alpha, more power of a test. Now, what is beta? Beta is your type 2 error. Now, notice these are inversely related to beta. So if you increase your alpha, you decrease beta. They are not complements. Increase effect size, you decrease beta. Now, we don't really control effect size. We control how much we sample, and we control our alpha, which is our rejection criteria. So with this knowledge, power is the ability to correctly reject the false null. Let's see how that applies to our question. What is power? The power is the probability of correctly, I like that, determining that the company is actually discriminating. Remember, if the null is false, then they really are discriminating. So if they are discriminating, we can figure that out. So a very powerful test will figure out and correctly determine a company is discriminating, because we'd be rejecting the false null because they're not innocent, they're guilty in this scenario. So a powerful test would figure it out. If the hypothesis is tested at the 5% instead of, now this is where they get me sometimes because I wish they just said, let's take this. Okay, here we go. They're saying it's going to be tested at the 5% instead of the 10%. Okay, so what are they doing right here? They're lowering alpha. Does that make sense? They're saying we're going to test at the 5 instead of the 10%. That means lower alpha. So what is, hey, Fran, great to see you here. Does this mean that when looking at the power of the test is the affected by the, yes, exactly. Fran, 100 points. So they're lowering alpha. What's going to happen to power if they lower alpha? So you got to flip all your arrows. Alex, great to see you here. People say hi in the chat or ask questions, whatever you got. If they lower alpha, what happens to power? So if they lower alpha, we've got if alpha increases, power goes up. But if it gets lower, Fran, great job right there. So the power of the test will decrease because the level of significance decreased. There we go. Remember, and just the slide right here, I think can help, that alpha and power, look at the colors and the arrows, they're directly related, but beta is inversely related to alpha. They're not complements, but exactly, if you increase alpha, you increase power. If you decrease alpha, you decrease power. There are 3 components, though, to power. Like, you don't just do a math, well, I guess you could. We don't have you do power calculations here, but it's not just alpha that impacts power. It's effect size, sample size, and alpha. So if you decrease alpha, you go from a 10% to 5% significance level, you will decrease the power of your test. Increasing alpha increases power. And that's a very good question right there. Pretty tricky because they're saying if the test is tested at the 5 instead of the 10, so they're decreasing alpha. They're saying you were at 10, you're going to 5, decrease of alpha, decrease of power. Great work and good practice right there. If the lawsuit is based on 34 employees, then how would it be, would the power be if it was based on 145 instead? So we're saying we're at 34 now, going from 145. So what's happening to sample size here? Sample size is whatting? Yeah, sure, Fran. We'll do that right after this. You bet, Fran. Thank you so much. What is happening to sample size right here, Fran? We were at 145. We're going to 34. So sample size is going what? We were at 145, and we're going down to 34, apparently. It's decreasing. So if sample size decreases, remember how these follow each other. If sample size decreases, what would happen to power? These are related in the same direction. So if sample size decreases, power will what? I've got like color coding arrows to tell you which ones are. It'll decrease, exactly. Because if sample size increases, power increases. But if sample size decreases, power decreases. I mean, maybe it'll make more sense to people if I draw this, but it just makes it confusing to have it going both ways. It's just that these follow each other. If you were just flip the whole graphic, sample size going down would mean beta would go up and power would go down. So which ones are inversely and positively? So the sample size, the power of the test would be lower. The sample size has decreased. And they make that clear with saying that. Just briefly, let's talk about the 3 things that impact power again. Thank you so much, Fran. This is meant for a review. So Fran, great questions. Okay, so have on your note card. Have on your note card the 3 things that impact power. Effect size, alpha, and sample size. Now, which one of those do we have the absolute most control over that the researcher can just decide at any moment? Which one of those do we have the absolute most control over that we can just be like, let's make it this. Let's just choose whatever we want. In sample size, we've got a little bit of control over. You might say, I don't got enough money to get more data. That's how much data do you have? More data, more power. Better pizza. Stat to 1. Alpha is the one we have the absolute most control over, but you got to be careful because you don't really want to play too many games with your alpha level. Alpha is the point at which you reject the null, so you can literally just change alpha like that. You don't have to do any extra work. You can just say, let's use this alpha instead. Does that make sense, Fran? Like alpha is just the point at which you reject the null. Whatever you want it to be, it can be. Now, with that said, you usually use an alpha of what? Alpha is usually this, unless otherwise stated, the point at which we reject the null. We don't usually play games with it. It's a little iffy to do this because this is your type 1 error rate. So alpha is your type 1. And alpha is type 1 error. The best way to remember this, and I talk about some ways to memorize in class especially, the best way is to remember that alpha is type 1 is to remember 1A, 2B. So if you just think letters and numbers like 1A, 2B, 1 is alpha and 2 is beta. So your type 1 error rate is alpha, which is your significance level also. It's just the point at which you reject the null. And if you reject the null more often, you will make more type 1 errors just by virtue of rejecting nulls when you shouldn't. Don't worry, you're like, well, why would I do that then? Well, sometimes you make mistakes when you do tests. Sometimes you come to the wrong conclusion. And that's alpha, and type 2 is beta. 1 minus alpha is not beta. The second thing, which we do have the second most control over, Fran, you are correct, is sample size. So sample size is inversely related to type 2 error. And just think about this, Fran. If I were to tell you, I want you to figure out how fast my friend can run a mile, would it be better if you watched them for 3 days run a mile or for 30 days run a mile? When would you be more certain and have a better ability to find results? If you watch them for 3 days or 30 days? For 30 days, right? So you increased your sample size. So by increasing sample size, you actually get a smaller standard error. That's mathematically what happens. The math behind this is literally the s over square root of n for some equations. And as n gets bigger, you have less uncertainty. This quantity, because you're dividing by n, square root rather, gets smaller. So the sample size increases the power of a test, making it easier for us to find results because it means less uncertainty, smaller standard error. The last thing is effect size, and I like to talk about basketball for this. Where's my basketball examples? I was playing LeBron in basketball today, and LeBron and I have a very big difference. Now, the effect size is only something we can estimate. We never really know the effect size. The effect size is the truth between the null and the difference between the null and the truth, excuse me. What does that mean? It means if I were to play my brother Darren, the difference, which no one really can quantify between Darren and I, is rather what? In terms of basketball skill, the difference between Darren and Brian is rather what? The difference between Darren and Brian, which is like if we assume Darren and Brian are the same, then there really is some difference. And that difference is probably what? What do you think? The difference is probably, I mean, I know you can't like say a number, but talk like in generalities. It's probably not that big, right? It's probably like, he's a bit better. He's a bit better. So might you make an error and say that Darren and Brian are the same? You might be like, Darren and Brian are the same, but if you made that error where you failed to reject this null, what kind of error did you make if you said, I couldn't find any evidence of a difference? Now, there really is a difference, but you've made a mistake right here because Darren and Brian, they're kind of similar, but they are different. So you would have made, if you didn't see the effect, if you couldn't find it and find a good enough reason to reject the null, even though we are different, but you just couldn't tell for certain, you would have made a type 2 error. But if we go with someone who's way better than me, way, way, way better, LeBron James is going to be way better and have a way bigger effect. Remember this, you don't really know this quantity. You're just trying to estimate it by watching us play basketball. But you would watch us play and be like, oh my gosh, I reject the null instantaneously because there's such a big effect, the difference between how good these players are. So we hypothesize that there is no difference down here between Brian and LeBron. And then the truth, what we're trying to measure, the true difference between Brian and LeBron is so big. Why this is a type 2 error? So in this example, Brian and Darren right here are truly different. Does that make sense? Like Darren is better than Brian. Does it make sense? So in this example right here, Darren is better than Brian, but it's a small difference. So you say, when you look at us play basketball, you say, well, I guess they're the same. I really can't tell a difference. But the truth, which you really don't know, which no one really knows, is Darren is actually better than Brian. But you fail to find that. You fail to reject the null and say, well, I guess Darren and Brian are about the same in their basketball skills. But you'd be less likely to make a type 2 error when you look at LeBron and I play because it's such a big effect. It's easy to see that. And we talked about medical today in class 2 with people being healthy or sick. and how doctors can only estimate like how far away you are, how sick you are. Doctors can't truly know, so doctors can make errors when there's a small effect size. They just try to like figure out how sick you are, and they're like, oh, let's see, how sick are they? And they're like, well, I can't tell. This person doesn't seem that sick. And then someone might be really sick. It's easier to tell, and that's the effect size right there. So really good practice. Fran, keep asking those questions if you got it. We're going to do the next question right here, chapter 16, homework 3. Woo, let's do it. Got it. Excellent work. Good practice on the concepts. Good conceptual learning. Let's do the next question. Okay, chapter 16, homework question 3. So this one is dealing with proportions and dealing with confidence intervals, all that good stuff. What is the first thing we're going to do? I think I accidentally deleted the sound clip, Leo.
Notation, brother.
No, I didn't. We're going to do some notation, brother. Okay. Leo's always there for us. It's not Leo, it's me. Here's our question right here. We got a random poll of 800 people. A lot of people get this one. This is going to be the sample size. And in the poll, they found this. They're asking, do you have a second job? So do you have a second job as a categorical question? So this is the proportion of people in the sample. Now be careful. This is p hat because it's a sample proportion, not p. P is the truth. It's what we probably would want to understand right here. It says estimate the true percentage. So we're going to have to estimate the true proportion using a 95% confidence interval. Now, the 95% confidence interval is a z-score of 1.96. We would give that to you on the test, but that's a classic number a lot of statisticians would probably know. If you're wondering how to find out that 1.96 z-score, MuBot's going to help us out by dropping the David M. Lane applet in the chat. We graph the middle, and this is a z-score, not a t. Oh, great job right there. Oh, we already got Q-hat. Fran, that's 100 points. Brian forgot to get some Q-hat right here. Q-hat is the complement of P-hat. Great job, Fran, right there. And Z is 1.96. And Fran has told us the rest of the notation. We go to the second button right here, and we go to between, and we enter in 95. There's a lot of ways to get the numbers. This is my preferred methodology to get 1.96 z-score. And once again, if you have your notation, when you get to a test question like this, you'll see on the formula sheet, you're doing p hat plus or minus z star. It means you get to pick it based on the confidence level. And the question might describe you which one. P hat times q hat over n square root. So now we're just going to plug in the numbers. I'm going to plug in those numbers. So we're going to go 0.08. My numbers look horrible. 0.08 plus or minus 1.96. If anyone wants to solve this with me, double check my math. That'd be great. I'm starting to go over here. And 800. Okay. This quantity over here is the margin of error. 100% suggests knowing that. That is the margin of error. The second part of it is also called the standard error. The margin of error is made up of the critical value. That's the standard error. I should have said that second. That's the standard error. And this quantity right here, we'll do it in a different color. This is the critical value that we use to create the confidence interval, the z-score, or the t. Okay, let's solve this. I usually solve for the margin of error first. Margin of error is 0.08. That's 0.92 divided by 800. I think everything went right. Times 1.96. And that's almost 2%. It's 1.9. 1.9. So I think we should be good. I re-express my interval then as the following. 0.08 plus or minus 0.019. And we're just going to add subtract that. So it'll be 0.61 to 0.099. Notice the margin of error just gets added and subtracted, as in we were just going up and down that amount from the mean at the center. So the mean of 0.08, add and subtract the value. Great job. Thank you, Fran, right there. Following along, really good practice to just solve the intervals and make sure you got it. Fran has confirmed the answers for us. Thank you, Fran. It's, working from, yeah, we got it. What does the confidence interval say about the pundit's claim? Well, the pundit thinks 4%. Now, this is a really great question because it's directly from how we do some test questions. You are 95% confident the true proportion of people who have a second job is contained in the interval 6.1% to 9.9. So because 4%, their claim, is not in the interval, we will reject it. We have strong evidence, so we're going to reject it. Remember, if we reject things, we have evidence against the claim. Is not, we have evidence that, wow, Fran, I'm throwing you 1,000 points. Fran, great practice, and thank you for being here. We're going to reject it, and they don't really say reject. I wish they said that, but because 4% is outside the interval, we definitely have evidence against the claim, because we wouldn't believe 4%. Just think about how you would talk about that. Someone's like, I believe 4% is true, and you're like, I don't think 4% is true. The interval goes from 6.1 to 9.9. You're telling me 4% is true? I don't believe you. I reject that. I have evidence against the claim. It doesn't say reject, but we would say I don't believe that's true. I have evidence against that. So remember, the alternative is the evidence-based claim. If you did not have evidence, then you'd have to believe their claim. If they could say 7%. They'd say, I think it's 7%. You say, well, I don't have evidence against that. That is in line with what I believe. And that's why we don't say accept the null, because if you could accept 8%, you could accept 7%. So we don't say that. We just say I can't reject it, which is weird. You're saying, well, that's believable. It doesn't mean you believe it. It's just like, that seems possible, given the null is true. These results, rather. Then we got one more homework one. Let's take a note on the homework. We will, let's see, 33, 42, chapter 16, homework question 4. A researcher developing scanner for hidden weapons at airports has failed to conclude that a new scanner is significantly better than the current scanner. He made his decision using the alpha of 0.025. Would he have made the same decision at 0.20, and how about at 0.005? So he failed to find evidence. Well, let's draw this out right here. Okay. This one's pretty interesting. It's false news. This one's a tough one, but if you draw it out, it makes it easier. Okay. So think about where he was at. They were at 0.025, and he didn't find it here. This means this was his alpha. Now, all we know is that their p-value, when they did the test, if he didn't find evidence, the p-value was what? If they didn't find evidence, the p-value had to be what? Remember, they didn't find evidence. So what do you know about the p-value for certain? You would know this about the p-value. You would know this for certain about the p-value if they did not find enough evidence, which means they did not reject the null. So for certain, we know right now the p-value is what? And be careful, this one changes multiple times. You have to draw it out usually, and then you can see it. So they said, well, we don't know what it was, but so they did not find results at the 0.025 alpha level. So if you did not find results, your p-value has to be what to 0.025? So they were using this originally, and they didn't find results right here. So it said they failed to find results with an alpha of this. So you know for certain the p-value is what now? I think they did not reject the null. So p-value has to be where? We don't know what it is for certain, but all we know is they didn't find results. This is a really good theory question too. We should just reword it and put it on the test. So if they didn't find results, the p-value has to be higher than alpha. When you fail to find results, it's because the p-value is higher than alpha. If the p-value is lower than alpha, you reject the null. They would have found results. So make sure to go by how your question's worded. They did not find results. Does that make sense? So the p-value has to be somewhere up here. So let's do a thing right here and say p-value right here. We don't know what the p-value is, but it's somewhere above 0.025. Does that make sense? And then we've got theoretical value 1, which I think they said 0.20. So this is first theoretical value is 0.20 alpha. I need to look, see if that's first or second. And yep, and 0.005. Okay, so then they went here and did a really low one. So that's theoretical value 2. So tell me this. Let's do theoretical value 2 first. Look at the p-value. I'm going to highlight it. Is what we know for certain about the p-value above 0.005? Yes or no? We know the p-value has to be at at or above 0.025. So is it above 0.005 for certain or no? So I've drawn this visually to say we did not reject here, which means the p-value has to be above it. So it has to be above this too, right? So we would make the same conclusion and fail to reject at the 0.005 level because the p-value has to be greater than that. But look what happens with this line right here, and I can show it a little bit better by doing this. The p-value has two scenarios with this other option. It could be here, or it could be here. We'll call it option A and option B. If the p-value is in option A, we would fail to reject because it's above it. If the p-value is down here, we would reject. So we don't know what would happen if we used an alpha of 0.20. We don't, because maybe the p-value was, like hypothetically, the p-value could have been this. And that would mean you're right around here. So you would not reject at the 0.025, but you would reject at the 0.20. But theoretically, the p-value could also be this, and then you'd be up here, and then it's above both alpha levels, and hence you would reject at both. So for the 0.20 level, we really don't know because the p-value is in that blue range, and we don't know if it's at or above or below 0.20. We do know it's above 0.005. Really good theory question, pretty tough, and this question changes, so please draw it out. Please try to make sure you understand when we reject, when we fail to reject, and alpha is something the researcher chooses for the point at which they're going to reject. Great question. So it would have been the same. It may have been different at the 0.20, but it would have been same at the 0.005. Woo, 100%. Good question. That's a really good tough one. But see if you get it. Hey, Eric, good to see you. Oh, Eric, I know it's Eric. Is that Eric from 2019? Is it? I think it is. Maybe it is. Well, we're about to do some quiz. So let's start some quiz up here. Is that Eric from a while ago? Eric, good to see you, man. Stats1 legend right here. Eric, let me give you some points. In this tiny little intermission, Mubot is in the chat. That is Eric. Eric, haven't seen you forever, man. We gave you a ton of points, man. There you go. You got 8 billion points. I don't even think he knows about Mubot. Check out your points. You got more points than me. Mubot will talk to you, give you points. You can say hi. You can say yo. You can see all those things. Eric's leading the way right now. More points than me. Eric, so good to see you. Mubot. Say hey, Mubot. He's new to the stream.
Hello, Eric. I will beatbox. We are going to do more quiz. Mubot is new to the channel. Eric is an original from original days. You have tons of points. Check your points now, Eric. They should be updated. And you will be at meme tier level with me and Brian. I will beatbox. Brian is going to do my quiz now.
Go away, Mubot. Let's do this. Check out your points anytime, Eric, by doing exclamation mark points in the chat. Hope you're doing well. I was like, I know who that is. Eric, one of the originals. Time for some more quiz questions. Woo! Points, Alex. Good to see you here. Okay. We're going to do new questions. We're going to do all the new questions. We don't want to burn out on energy. We did job discrimination. We did workers. Okay, there we go. Well, we got to use. Did we do all the tough questions? Well. Let's check this out. Let's do multiple choices. Knock those out. Okay, 41, 28, chapter 16, quiz. Multiple choice. Here we go. What is it? President's approval. Yeah, let's do president approval. We'll do that next here, friend. You got it. Okay, we got some easy stuff here, friend. You ready? Please help me out with this one or two in the chat. You ready? What type of error is made when a true null is rejected? Boom, friend. Easy. Easy points on the test. How do we know that? Is because in a type 1, null is true and we reject it. That's a T, that's a 1. In a type 2, the null is false and we fail to reject it. We're going to do a little more multiple choice, friend. Then we got yours coming up next right here. Let's see what other multiple choice we got. What type of error is made when the null is false? Ooh, look at them being tricky. They say not rejected, but what would you rather say? That means the same thing. I'll say that sometimes, but if we're talking about this error and we talk about this, what are we talking about? We'd say the null is false and we what? Which is the same thing as not reject, but what else? How would you phrase it? The null is false and we what? Which means not reject. It is a type 2. And make sure to say in a type 2, the null is false and we fail to reject it. So in a type 2, the null is false and we fail to reject it. And the reason we like to say that is because of the 2 F's. In a type 2, the null is false and we fail to reject it. Good stuff. Just going to knock out all the multiple choices. What is the probability that the test correctly rejects a false null? Now, it's got 3 components right here. It says correctly rejects false null. So which one is this? This is the what? This quantity is known as 1 minus beta mathematically. It's not making a type 2 error. So it's not type 2 error because this quantity is known as not making a type 2 error to correctly reject the false null. This, see if you know it, this is the power of the test, exactly. And we've got it written out right here. Great job, Eric. Oh, don't worry, Eric. Good work right there. We're going to throw some more points in the chat. This is 100 points right there. This is the ability to correctly reject the false null. 3 key components right there are the effect size, the alpha, and the sample size. We did a really great review of this earlier. Eric, don't worry. Good practice. It's good stats practice. And this is the end of the course. This is the tough stuff. Eric, we're throwing you 1,000 points. Eric, check your points. You are leading the way on points. Fran, 2,000 points for being here and throwing that positivity right there. We're going crazy today. So, Eric, don't worry and check out your points because you are leading the way on points. I'll tell you that much. And what do we have right here? What is the name of the threshold? So now we have the threshold at which we reject the null. What is that point we decide on? That is like, I'm rejecting the null here. I can just make it up, whatever I want it to be. Now, it does have to be between 0 and 1. LPH. What is... Alpha level. Oh, oh, did you hit the caps lock? And then... I think, yeah, you... I got a little, like, there you go. Because I think you hit the A, so the caps lock is like, what's wrong? So, and then Eric right there, another 100 points. You got it, Eric. Great job. That's the alpha significance level. Great job, Eric. Good work. Okay. If the p-value is smaller than alpha, what do we do? Which it says significance level. What do we do? P-value is low. P-value is high. Just let it fly. So if the p-value is low, what should you do? Now, do not say the wrong... There's one wrong answer that'll cause me great harm. If the p-value is low, if the p-value is high, just let it fly. When the p-value is lower than alpha. So when the p-value is lower than alpha. So for those who haven't heard in our class, when the p-value is lower than alpha, reject the null. But when the p-value is low, reject the null. When the p-value is high, just let it fly. So it says the p-value was smaller than alpha, our significance level. We're going to reject the null. Oh, wait. So when the p-value is low, reject the null. When the p-value is high, say, Eric, good job right there. No worries. Great job, Fran. 100 points, Fran, right there. When the p-value is low, reject the null. When the p-value is high, just let it fly. So the p-value was lower than, and they're saying alpha right here. Good practice. We all need practice. Which of the following is the correct interpretation of a p-value? Now, a p-value is a conditional probability. So we're saying the probability of our results or results from our stream given the null is true. That is not very small. That's what they're saying. So a p-value that's not very small is one we would not reject. So what we saw in our sample data was not surprising. So it seemed likely. So all they're saying right here is high p-value. High p-value means a likely result, not surprising. So it wouldn't be a rare event. That'd be a low p-value, unlikely result. Not surprising, fail to reject. Great job. Good recovery, Fran, right there. If it's not surprising, we would, like, if the null is true, this was likely to see. So I guess the null is true. So we would fail to reject the null. Afraid I'm going to get one wrong. I'm like, all right. Which of the following, we've got some tricky ones right here. Which of the followings are mistakes that can be made? Okay, the null is true. So listen carefully to this question. If the null is true, what should we do with the null? If the null is true, I think, Fran, you got it right away. If the null is true, we should what it? Be very careful. I'm asking in a reverse way. If the null is true, we should what it? Be careful. I think people might see it, but just think if the null is true, we should do this. Or shouldn't, whichever way you want to describe it. If the null is true, we should not reject it. This is an error. I think Fran, great job, Fran, right there. If the null is true, we should not reject it. That's an error. The null is true. Why would you reject that? You've made an error. If the null is true, you don't reject it. That's the correct statement. And then it is false and we fail to reject it, perfectly describing a type 2 error, because if it's false, you should reject it. If the null is false, you should reject it. They could have added a fourth one right here. The null is false and you reject it, and that'd be fine. If it's false, we should reject it. Exactly, Fran. Great follow-up, because they could have added like a fourth. That would be a correct thing to do. If the null is false, you should reject it. But if the null is false and you fail to reject it, you've made an error. So it is 1 and 3. Excellent work, Fran. We're going to do the presence one here in a moment. Is that it? Oh, no one. What is the name for the difference between the null and the truth? Now, this is the thing we can't measure. So these are really good just definition things. This is what we have to just theorize about. Like, if we talk about the difference between the null and the truth, then what we're trying to measure, it's effect size, exactly. That is effect size, which, once again, is a theoretical quantity for just how far away certain values are from each other. Like, when Brian plays, we always talk about Brian playing his brother or LeBron in basketball, and the effect size is the actual difference between the individuals. You don't really know, exactly, basketball example, like, you don't really know how much better Brian is than Darren or Darren is than Brian, but this is the effect size. Now, if Brian plays someone way better, it'd be easier to see the effect size, because you might assume that Brian and this individual are the same, but there's a very large difference. The null is that they have no difference in their basketball points, and then the effect size is that there's a very, very large difference. Great job, Fran, right there, remembering. A lot of multiple choice. We'll do the bank lending here in a moment. We want to find the presence one. Thank you, Fran, for asking. Here it is. I think we found it, Fran. I think we got 2 more questions after this, and Fran wanted president's questions, so we're doing that next right here. This is 49 minutes and 25 seconds in chapter 16 quiz. And president's approval. Okay, here we go. Thank you, Fran, and great work. Okay, whoop, disappeared. Okay, in a recent poll. Now, Fran, we got to channel Leo right here. What is Leo going to tell us to do? We got some poll numbers right here. What's Leo saying?
Notation, brother.
I don't know if I like that or not. It scares me. Leo's going to tell us to write down that notation. Thank you, Leo. Always here with us, Leo. So Leo's going to say, write down that notation. So what do we got? What do we got? We're getting all the notation. What do we got? Oh, thank you. If people like it, it's going to stay. Recent poll. Great job. And then this, Fran already put the sample size, and then this is usually where people get stuck. That's going to be the Z-score. The Z-score is 1.7. Thank you, Eric. We got so many new things, Eric.
It doesn't matter.
We got a lot of new crazy wackiness here. A lot of randomness. So many buttons for me to press. I'll calm down. What am I doing? I'm adding points. I was on autopilot there. Oh, the caffeine. So we got the David M. Lane applet, and the Z-score is 1.645. This would be given to you on the test. We go right here. We put in the middle 90% and get between, and notice how it looks like a confidence interval where you got a plus or minus. This was just work done to get the Z-score of 1.645. I've memorized it because I've done a lot of these problems. So all we wanted was this Z-score. Now we need to go in and make the confidence interval, which is going to be p hat plus or minus z star, star because we can pick it, square root p hat q hat over n. And so the p hat is going to be 0.46 plus or minus z of 1.645 square root 0.046 times 0.54 over 900. And this will give us the confidence interval. Please note, as we always like to point out, that we do have a margin of error right here. This is the margin of error, which I solve for first. And that's the plus or minus on the interval, which is going to make it symmetric around the margin or the center of the interval, which is our estimate from the sample. 0.46 times 0.54. Don't make a calculator error. 900 divide by square root times 1.645, and we get 2.7%. Does it want to 3 decimals? I hope it does, because we're going to round it to that, and then we'll find out the hard way. And so 0.46, there we go, plus or minus, and 0.027 margin of error. That, once again, is the margin of error still the plus or minus. Now we just add and subtract, and 4.33, and then that's the lower, and then the upper is 0.487. There we go. Hopefully 3 decimals. We'll find out. So does that make sense, Fran, right there? Let me know. Thank you so much, Fran, for all your work. 3 decimals. What was it? It was 0.433. Well, that's not 0. Really? Really? Awesome. I think that's got it. Based on this confidence interval, can the null hypothesis be rejected? Are they serious? What do you notice about their null hypothesis? You don't even need statistics for this. Let me tell you. So their hypothesized value, this is the way random questions can generate sometimes. Their hypothesized value is what? Now, if you look at this question, it might seem a little confusing, because if I'm reading it properly, that is their hypothesized value. That is not their sample value. This is what they are hypothesizing. It's the same as what we saw in the sample. So think about this. They're like, hey, we think you've got a 46% approval rate. And they're like, oh, let's go look at this. And then they come back and like, yeah, our sample found 46%. You don't even need the confidence interval, because what's at the center of the confidence interval? Now, I'm not suggesting to do this, but your best estimate of what the president's approval rating is what right now? Like, if you had to guess the president's approval rating, what would you guess? Which is at the center of the interval. You don't even need the margin of error right here. Your best guess, and you're not saying 46 is true, it's 46 is at the center of the interval. You don't even need the margin of error. You're just like, well, we think you're at 46%, and the poll shows 46%, so 46 is believable. Now, if they had hypothesized a number which would make it more interesting, like 49%, which we still need 46 here at the center, but let's say, this is not the question, but let's say it said 49% is the hypothesized. What do you notice about P naught right here? This is just a hypothetical, like if they had given us 49%. What do you notice there about 49% if they had said they hypothesized? I've changed the question now to make it a little more interesting. What would you do with that value, and why would you do that? So if they hypothesized 49% is the approval rate, and they said, oh, we think it's about 49%, and then they did this poll, they found out the interval trying to estimate the approval rating, you would say, this value I do what? This value I do what? You'd say, that value of 49% doesn't really seem believable, because I'm 90% confident that the true proportion of people who approve of the president is contained in the interval 43.3% to 48.7%, so I reject this value. So in this hypothetical version of the problem that I just made up, we would reject the value that's hypothesized as true because it's not contained within the confidence interval. Our value right here is at the very center, so you would fail to reject it. Do we do it? Woo! A little scared there. It's at the very center of the interval, so they just literally give us the value in the interval. Interesting. Ooh, I like it. So statements about p-values. This is a fun one. Statements about p-values. Okay, here we go. Using an alpha level. Now, alpha is the bar at which you reject. A p-value of 0.02 results in rejecting the null. Is that true or false, Fran? You're welcome, Fran. If you have to off, great job. Thank you, Fran, so much for being here. I love working through the questions with people. Great practice, Fran. If you have to head off, that's fine. First one's true. Fran. You are very correct. P-value less than alpha, reject the null hypothesis. Awesome work. We're not going to submit that yet. That is very true, Fran. Correct. The alpha level depends on the sample size.
It doesn't matter.
No, you just pick your alpha. You just say, usually you choose 0.05. The alpha level is just decided by the researcher. The alpha level is set independently, does not depend on sample size. You just say, I want to use this alpha. I'll just pick it. I'm setting the bar here for when I reject. Boom, Fran, destroying it. Choose the more points. Choose the so with an alpha level 0.01, a p-value of 0.05 results no. Stop. Because p-value is higher than alpha, so we'd fail to reject. This is false because only a p-value less than alpha results in rejecting the null. So that should be right there. You're welcome. Have a great evening, Fran. Thank you so much for all your work. The last one right here, we're using an alpha of 0.05, 0.08 means the null hypothesis is true. No. You don't say the null is true. You just say I don't reject it. So this statement is false because no, we don't indicate things are true. We either reject or not reject. The statement is false because p-value greater than alpha only indicates that there's not enough. Yeah, this sounds accurate. This statement is false because p-value greater than alpha only indicates that there's not enough evidence. No, we don't say accept the null. Bad. Don't say accept. We don't say things are true. We don't say we don't accept things. The null we don't know which of them is true. We can make errors. You might say, well, weren't you talking about the null is true? Well, that's a statement of reality that we don't know. We don't say, I know the null is true. You never say, I know this person is innocent. I mean, we might say that, but in statistics, we say, we don't have evidence of their guilt. We don't have good enough evidence. So in this instance, right here, this is the correct way. This statement is false. A p-value greater than the alpha level only indicates there was not enough evidence to reject the null hypothesis. Oh, wait. Cancel. Mubot, you're supposed to tell me not to do that. We got one more question. We did these other ones, these first four right here. Are they in the same order as the quiz? Here we go. A bank is deciding. Let's put the time note in here. Time note to do it. 59:25. Chapter 16. Quiz. Bank loans. Okay. So this bank, a lot of words up there. We like words. A lot of words of the bank is deciding whether or not they should loan money. We need to figure out their null hypothesis. I think they state that at one point pretty clearly. Their null hypothesis, we can think of this as a hypothesis test. Since the bank makes its profit from interest collected, their null is that the applicant will repay the loan. So the null is give money. The alternative is don't give money. They need evidence to not give money. If the person's score falls below the cutoff, so they need like a certain credit score or something like that, the bank will reject it and deny it. Okay. So we know what's going on right here. Let's write. Oh, no. Null hypothesis. Null hypothesis. Loan money. Alternative. No money. Okay. No loan. Go. Okay. In a type 1 error, the null is true. Is that a type 1 we're talking about? When a person defaults on a loan, what type of error did the bank make? Let's check out the type 1 error, right? And that'll tell us which error we're talking about here. In a type 1 error, the null is true. So this is true. The bank should loan them money. But the bank is going to reject that. So this is a type 1. In a type 1, the null is true. The bank should loan them money. So they think they have evidence to not loan the person money. So a type 1 error, remember type 1 null is true, is when the bank does not loan someone money they should loan money to, because they should, the null is true, they should loan them money, and the bank says that. So what kind of error is made when the bank misses an opportunity? That's the type 1, and let's do the type 2 over here, because the first one's going to be type 2. In a type 2 error, the null is false. So that this is a false statement, but we are going to fail to reject it. So you can deduce that it is true that they should have loaned money, or should have not loaned money. Oops. Weird how they phrase this one. The null is false, but we failed to reject it. So it is false that they should loan them money. It is a false, like you should say, we should loan them money. You say, that's a false statement. Somehow we would know this in the end because they, are not they're going to default on their loan. So the truth is we should not have loaned them money. They should have got no loan. So this is when a person defaults, we shouldn't have loaned the money. That is a type 2 error right there. Suppose the bank, let's lower the font. Suppose the bank lowers the cutoff. Okay, so they're making it easier. Got the tough questions here at the end. So they're lowering the cutoff rate. So if they're lowering the cutoff rate, this one is so interesting. I think so now. I don't want to make sure I don't want to get it reversed. So you think they're going to allow more people to get loans, right? So which one of these are they adjusting? If they lower the cutoff rate, it's because someone needs to be below, they are going to fail to reject the null. It's the same thing as alpha. Because by lowering, watch me get it wrong. Because they're have it at like 250, and it's neat because it's the same way it works. They're going to lower the bar down. So now they need more evidence to not loan money. Does that make sense? Because only if someone has a credit score below. So their credit score is the alpha. I never thought of it that way for this question. So the credit score, I wish they said it's credit score. I don't know. They don't want to advertise that or something. If they set it to 200, this right here is your alpha that they're using figuratively. And then the credit score is the p-value. So if they raise the bar, they're raising alpha. Is it A, Eric? I think it's analogous to alpha. So I think it's going to be lower alpha. So from 250 to 200, that's going to be a lower alpha because they need more evidence to not give someone a loan. What impact does changing the cutoff value have on the chance of each error? So if, as we're saying right here, this is alpha. So alpha going down would decrease type 1, where alpha going up would increase type 2 errors. So remember, 1A, 2B. So if we decrease alpha, watch me get all this wrong. Last question. Don't want to make mistakes. If we decrease alpha, we decrease type 1 errors. If we decrease type 1 errors, we increase type 2 errors. So it should be, what type of impact does change the cutoff have on the chance of each error? We are decreasing type 1 and increasing type 2. Decrease type 1, increase type 2. Woo! Woo! Good stuff. Got every question right here. Tough stuff. Good quiz. And if you're looking for the first 4 questions on this quiz, does it go in the same order? That's the first we did. That was like the third. So I think it's almost the same, but it goes in a little different order. Well, that's got all of them. With that, Eric, so good seeing you. We're going to head off, take a break, have some dinner. Eric, keep up the great work. Fran, thank you for all the great practice here. And if you have questions, email me. Talk to you later, everyone. Keep up the great work. Bye, everybody. Bye.